One of the prior sections that we studied rational functions in was section 3.1 when we learned to find the domain of a rational function from its equation. So we're going to spend a few minutes just reviewing this concept. So it says under finding the domain of a rational function that to find the domain of a rational function, you need to set the denominator equal to 0 and solve to find the bad spots. The domain is going to be all real numbers except the bad spots. Okay, so remember, why is this true? Why is this the method for finding the domain of a rational function? Well, if you have a fraction, you can never have a 0 denominator. Okay, if you divide by 0, if you divide anything by 0, that's bad. Okay, so we look for the bad spots by figuring out what x values make the bottom equal to 0, and then our domain is going to be all real numbers except for those bad spots. Okay, remember, you never have to look at the numerator unless there is an underlying condition like a square root in the numerator. That's an instance where you would have to examine the numerator because the square root would produce another condition. But if you don't see something like a square root in the numerator, you don't have to worry about the numerator. Okay, so we're just going to revisit finding the domain of a rational function. In example 1, it says state the domain of each rational function using interval notation. So in part A, our rational function is q of x is equal to 6 over x plus 3 quantity times the quantity 4 minus x. All right, so all you need to do is figure out the bad spots. Okay, so to figure out the bad spots, we are going to take the bottom and set it equal to 0 and solve. Okay, so we're trying to figure out the x values that make the bottom 0 if you were to plug them in. Okay, so how do we solve something like this? Okay, your first thought might be, well, I need to FOIL this out. Okay, so if you did that, you would get 4x, and then you would get negative x squared, and then plus 12, and then minus 3x. Okay, so actually you're making it more complicated. Okay, if you clean this up, you should realize, if I'm just combining like terms here, the denominator is quadratic. Okay, so we're trying to solve a quadratic equation, and how do you do that? Well, you need to either factor or use the quadratic formula. Okay, as the denominator is written, x plus 3 times 4 minus x, it's already factored. Okay, so let's erase this. We don't need to multiply it out. Okay, we've already got it factored. We have two factors, two things that we're multiplying together. Okay, we need to take each factor, set it to 0, and solve. Okay, so we're going to take x plus 3, set it to 0, and then we're going to take 4 minus x, set it equal to 0, and now we're going to solve each one. So for x plus 3, I'm going to subtract 3 from both sides, so I get x equals negative 3 is a bad spot. And then on this side, I'm just going to add x to both sides, and this tells me that x equals 4. Okay, these are your bad spots. Okay, and you can check this. If you go back to the original function and you plug in negative 3 plus positive 3 is going to give you 0. 0 times anything is going to be 0 in the denominator. Likewise, if you plug in 4 into the second factor, 4 minus 4 is going to give you 0. 0 times anything is going to give you 0 in the bottom. Okay, these are your two bad spots. Okay, if you remember, we have already learned about how to write your domain in interval notation. Okay, so we're going to just revisit that. So what you should do to get it right, you need to draw yourself a number line that is going to track all your good and bad x spots. Okay, so think of this as the x-axis. It's tracking the x values you can and can't plug in. Okay, on your number line, you want to line up you want to put your bad spots on there. And you want to put them in order. If you were walking on this number line from left to right, you would first hit negative 3, and then later you would hit positive 4. Okay, these are both bad spots, so we want to get rid of them by putting an open circle. Okay, but everything else is good. Okay, so in red, I'm shading all the good x values. Okay, then you're going to walk the number line from left to right. Okay, So if we're way out here, okay, if you can see where my cursor is, that's negative infinity. Okay, then we're going to fall in a hole at -3. We don't want to include -3, so we put a parentheses, and then we pick up right on the other side of -3. So we're going to write -3, but exclude it with parentheses, and then we're going to be able to walk until we get to 4. At 4, we fall in a hole, so we put another parentheses to exclude it. But as soon as we dig out of the 4 hole, we will travel along again. So we pick up at 4, put a parentheses to exclude it, and then we walk off to positive infinity. Okay. If you want, you can put a little union symbol in between each pair of intervals. Okay. This is the way you would write all real numbers except for -3 and +4. Okay. So I'll go ahead and box that. This is going to be your answer. Okay. All right. Let's try another one. In part B, our rational function is -x times the quantity 1 minus x. All of that is over 3x squared plus 5x minus 2. Okay, same thing. To find our bad spots, we need to examine the denominator. Okay, there is nothing terrible about the numerator. There's no square root going on, so we don't have to deal with the numerator. Okay, so we're going to take the denominator and set it equal to 0. So we're going to get 3x squared plus 5x minus 2. Okay, we need to figure out what x values you would plug in that's going to give you a 0 value. Okay, we don't want to have 0 in the denominator. Okay, we've got another quadratic equation. So you can either factor this or you can use the quadratic formula. Okay, I'll use a quadratic formula here because we factored last time. Okay, so one side has to be 0 before you begin. Okay, we need to identify our a, b, and c. So a is going to be 3, the number in front of x squared. B is going to be the number in front of x, which is 5. C is the constant, which is -2. We're going to plug all of this into x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so that's going to give us -5 plus or minus the square root of 5 squared minus 4 times 3 times -2 all over 2 times 3. Okay. All right. So if we simplify this, we will get our bad spots. Okay. So this is going to be -5 plus or minus the square root of 25 minus times minus will give you plus. Okay. 4 times 3 is 12 times 2 is 24 all over 6. Okay. So this is going to be -5 plus or minus the square root of 49 all over 6. Okay, I am running out of room here, so I'm going to actually go over here. Okay, so we're going to have -5 plus or minus the square root of 49 is 7. Okay, so the numerator is going to be -5 plus or minus 7 all over 6. Okay, this is going to produce 2 bad spots. The first one we get by picking the plus sign in the middle. So -5 plus 7 divided by 6. Okay, this is going to be 2 over 6, which is 1/3. Okay, so that's one bad spot. The other bad spot we get by picking the minus in the middle. So that's going to be -5 minus 7 over 6, or -12 over 6, which is -2. Okay, so we have 2 bad spots. Okay, the domain is going to be all real numbers except for x equals 1/3 and x equals -2. Okay, you would draw the same kind of number line to help you write down the interval notation. So if we do that here, let me draw my number line. Okay, so here we go. I'm going to put my bad spots on here and put them in order from left to right. If I were walking from left to right, I would first hit the negative number and then later the positive number. These are both bad, so I'm going to draw a circle, open circle to get rid of them. Everything else is good. Okay, so to write down the interval notation from left to right, okay, we would be walking from -infinity, fall in a hole at -2, so we're going to exclude -2 with parentheses, pick up on the other side of -2, so we're still excluding -2 with parentheses, walk up until 1/3. Okay, we fall in a hole at 1/3, so we've got to exclude it with parentheses. Okay, and then we dig ourselves out of the hole, pick up on the other side of 1/3, we're still excluding it with parentheses, walk off to positive infinity. Okay, so here is your domain. This is how you're going to write all real numbers except for -2 and +1/3.